Hello, we are here to introduce the design pattern called servant, and my name is Jiawei Zhao.
My name is Haotian Zhan.
And we are going to first introduce the definition and some of its example. So the servant design pattern is classified as one of the behavioral patterns. The servant design pattern is defined as an object used to offer some functionality to a group of classes without designing that functionality in each of them. A servant is a class whose instance provides methods that take care of a desired service, while objects for which the servant does something are taken as parameters. Servant is used for providing some behavior to a group of classes instead of defining those behaviors in each of the classes, or when we cannot factor out this behavior in the common parent classes. It is defined once in the servant when we want some objects to perform a common action and don't want to define its action as a method in every class. And for a good real-world example would be, let's say there are two instance objects that the user desires to move, a rectangle and a triangle. They are different classes. Instead of writing two different move methods for each of the two objects, we can implement a servant class that take care of the moving action, that takes in the moving parameter from the serviced object, which will be the rectangle and triangle. Such implementation results in clear logic and avoids redundant code. Structure. So there are four structures in the servant design pattern. The first is the user. The user makes a request via the main function, which the requests are made to the serviced object. The serviced object is objects that desires for some service from the servant. They implement the servant interface in order to serve by the servant. And the servant. So the servant is the class that offers the desired service for the serviced objects. The method in the servant classes takes in the servant interfaces as parameter, which the serviced objects implements from. And lastly, the servant interface. The servant interface specifies what serviced classes needs to implement to be serviced by the servant. The method in servant takes interface as parameter. And this is a UML diagram of the servant design pattern. As we can see, the user gives the instruction from the main, which is passed to the serviced object, in which they should all share by a common interface. Then the instruction and the parameters are passed to the servant object. The servant object will be communicating with the servant interface, which making sure the instruction is viable. Then return the request to the user directly through the interface or to the user directive. And consequences. So some of the advantages of using servant. So the servant design pattern is a good idea when more than one classes share the same behavior. Then instead of implementing the behavior multiple times for different classes by writing redundant code, we can wrap that behavior into a servant class and make the different objects accessing the servant classes from that behavior. Such implementation results in a more clear logic and clear code. And some of the disadvantages. In terms of negative consequences, there aren't any major ones. The only ones that I can think of are that developers needs to be careful when deciding to use such pattern, making sure that such pattern can be efficient with the program. If the program is used if the design pattern is used when it's unneeded, it can make the program more complicated and create a large amount of unwanted code or logic. And such a design pattern is not needed when objects don't share behavior together.
So now I'm going to talk about the implementation details. So to implement a servant, as we just mentioned before, so there are four key components of it: the user, the servant class, the served objects, and one common interface. So all the served objects should implement common interface in. So we will see an example of it. So in this example, the common interface is called iService, and then the servant class is offering its functionality to the classes implementing. So there are two ways of implementing the servant design pattern. We just introduced the first way of implementing it. So the first UML diagram is the one we just saw before, in which user knows about the served classes and the user don't know about the servant. The user will call the service classes, and the service classes then ask the service interface to achieve the desired functionality. And the second UML diagram is the case that user do not know the served classes, but the user know about the servant. The service classes do not also do not know about the servant, but they implementing the same interface called iService, and it send a message with the user's request to the servant instance, passing the served object as parameter, which will achieve our functionality. So now we need to talk about how to implement the servant. So there are several steps. First, we need to know what we want our servant to do. That is what our servant instance must provide to the servant methods. And then we need to define those servant classes to be served, which will implement the same interface. After that, we have to define the interface, specifying what service class need to be implemented, and those will be served by the servant. And the fourth step is that we need to define our servant, which is the key of the whole servant design pattern, and that will offer its functionality to the servant classes implementing the servant interface. And after that, the whole process is done. So we just implement a defined interface with the service classes. So let's move into the sample code. The servant in this example is just used to move objects from one position to another. So it has a servant class called mover, has two service classes, triangle and a square, and one interface called iMovable. So first we need to define the iMovable interface. The user will know about the mover class and call the method inside the mover with the service object of the iMovable as parameter. So here is how we define this iMovable interface. It basically just have two methods: set position and get position. So here are the two service classes that implement the iMovable interface we just have. One is triangle, one is square. So they both override the set position method and get position method we just did in the iMovable interface. So let's then talk about our servant class. So here is the servant class. It has a method called moveTo, which will be called later by the user, and it takes a service object of type iMovable as parameter and the position we want to move our shape to. Lastly, we can test to see if our servant is successfully served. So we just writing a mover test, try to call the move to method inside the servant class, and to see can we move two different classes of the same instance to different position. Here are our references.
Thank you.
Thank you. So that's all of our presentation.